You've already met the POH, the Pilot's Operating Handbook. Now you'll have a chance to look at it in depth and plumb some of that depth for specific performance information on your Skyhawk. As you recall, the principal difference between the Pilot's Operating Handbook, the POH, and the Pilot's Information Manual, the PIM, is that the POH has been compiled for a specific serial number airplane. The POH is the biggest part of the O in Aero. However, it'll be okay to use the PIM in your course packet to study the material we're about to introduce. For over a quarter of a century, aircraft built by American general aviation manufacturers have utilized a standard arrangement for their POHs. Your Skyhawk is no exception. Section 1 is usually pretty generic. It has conversion tables, lists of symbols, abbreviations, and terminology. It furnishes descriptive data and dimensions for the specific aircraft as well. Section 2 is devoted to limitations. Some of them, like the various airspeeds, you already know. If there is a limit of any kind on anything, it's in Section 2. Section 3 covers emergency procedures. You've covered those thoroughly in a previous lesson. Section 4 is the basic how to fly this bird instruction. It's arranged in flight order: pre-flight, taxi, takeoff, climb, cruise, descent, etc. Plus, the official aircraft checklist are part of Chapter 4. Section 5 contains performance data, and in just a bit you'll discover how to find what you need there. Section 6 includes weight and balance data, and it's the place where the POH differs from the PIM. This is the W, as in weight and balance, in Aero. Section 7 is how things work. What does it mean when this light comes on section? Section 8 is the care and feeding section, and it's a must for peace of mind on an overnight cross-country. Section 9 provides a collection of operating manuals for all the equipment not produced by the airframe or engine manufacturer. The clock is wrong. How do I reset it? Section 9, Supplement 9. How do I program the channels on the comm radio? Section 9, Supplement 1. All the extra goodies are in there. So now you know where everything is. Let's go back and learn how to extract some of the information stuffed into Section 5, the performance section. The first 8 pages tell you how to use the more complicated charts and tables at the end of Section 5. Let's leave those for the next lesson and look at the simpler presentations first. Figure 5-1 is actually 2 pages, or sheets as the legend calls them. You've seen them before when we discussed errors in airspeed indication. Figure 5-2 is a temperature conversion chart. You'll need this if by some chance surface temperatures are given to you in Fahrenheit. Next, you have stall speed tables at the extreme ranges of center of gravity. As you can see, they're almost identical in your Skyhawk, but this isn't true for all airplanes, which is why the regulations say that both conditions must be shown. Skipping to the maximum rate of climb table, figure 5-6, notice that it shows the airspeed you need to maintain in order to get the climb performance depicted. And now a little challenge for you. Over on the left edge of the chart, you'll find pressure altitude. And at the head of the columns, you find temperature. Pressure, altitude, and temperature, what's that? Right, it's density altitude. Instead of showing the density altitude at the intersection of each temperature, pressure, altitude combination, the engineers have plugged in the performance you can expect to find for that particular value of density altitude. It just saves a step. You'll discover this particular scheme repeated throughout the performance section. And now you can skip ahead to figures 5-9 and 5-10. They complement each other and show you what you can expect from a full tank of fuel at various power settings. Figure 5-9 shows how far you can go, and figure 5-10 shows you how long it will take you. For example, you're planning a flight at 7,500 feet and are wondering how far you can realistically go with full fuel at 70% power. Here's how you do it. Enter the chart, the first one, 5-9, at 7,500 feet, halfway between 8,000 and the unlabeled 7,000 foot line. Now move horizontally across to the 70% power line. Then you drop straight down and read 635 miles, right around here. You can also see that you should expect to enjoy a true airspeed in excess of 113 knots. Basically now, to find out how long it's going to take you, you do the same thing on chart 5-10. You enter the chart at 7,500 foot line, find the 70% power line, and drop down to the bottom of the chart and read 5.6 hours. Both charts allow for fuel used getting airborne and climbing to altitude. They also provide for a 45-minute reserve on arrival. Since there's no way for these charts to include the effects of wind or variation from standard conditions, you can't use them for planning an actual flight. Their purpose is to give you an idea whether a proposed flight is even possible. Think of them as possible, impossible gauges. So now you know about some of the possibilities offered in your pilot's operating handbook. And if you haven't dozed off yet, you'll find even more in the next lesson.